My name is Marcin Kliks, and I'd like to thank the organizer, and I want you to give an applause for organizer for organizing such a great conference. Really good. So let me introduce myself in a few words. I'm a literally server-side developer because I build software for data centers. So it's actually funny to be on the ServerSide.swift conference. I'm a DevOps team lead at Allegro. Some of my work you can find on GitHub, like Ralph CMDB, which I recommend if you manage servers or some infrastructure stuff. By the way, I work at Allegro, which is the biggest e-commerce platform in Poland. It's used by 20 million users, and we have 1,600 employees. And we work really hard to make the best e-commerce platform for our customers. This is how Allegro looks like. Our platform consists of 500 microservices written in Java. So for technical services, we use Python and Golang, and for business logic, we use Java. Our Mesos and Marathon, our deployment is the deployment platform. We also have 2 custom data centers which we manage. So you can ask what I'm doing here. It's Java, Python. This is the story. The story of ServerSide.swift at Allegro begins 1 year ago. We discovered problems with performance on our site. It was quite slow to load on mobile. And there were many reasons for that, of course. There was large CSS, slow JavaScripts, and large images, as we all know. But large images on the front page was one of the biggest points. So especially showcase area where we had to use PNG format very often. And this format didn't compress very well. So for example, this image was 110 kilobytes. And it might look like it's small size, but it was actually slow when you load it on mobile. So we wanted to be fast and load in just 3 seconds on desktop. So at first we were over the budget pretty much all the time. So we looked closer at PNG images and how you can optimize them. You can think of replacing it with WebP format, but it's still not implemented in major browsers. It's only Chrome. So you pretty much have to stick with good old PNGs and JPEGs for some time. But we wanted to have performance solution for thousands of images. So we've made a lot of research, and after a lot of experiments, we found pkg-config library, which is a C library created by Kornel Lesiński for recompressing PNG files. And the algorithm is based on, be prepared, high-quality palette generation with the best vector quantization out there. It also comes with adaptive dithering to make images look even better. So in short, it sounds smart, right? But it's actually genius because it reduces the size by about 30 up to 40%. But it only works with PNG files, of course. So what to do with JPEG files? And well, this is where compressor called MosJPEG came a solution. It uses trellis quantization, which is quite fast and brings at least 30% reduction in size. So you can think that, okay, you might think it's done. You found libraries, just wrap it in Java, microservice, and that's it. So the compression is easier. Actually, it's not easy. It's not so easy, and I will tell you why. Because first of all, it's very memory and CPU intensive. You have to allocate memory, decompress, and recompress again with optimizations and free the memory. And you need at least 40 times RAM as the original image size on average. So for 4 megabytes image, you need at least 160 megabytes of RAM just to decompress it, because you have to create a bitmap in memory to make optimizations. So if you try to wrap it in Java, the heap allocation will completely destroy the performance, and we want it to scale. So when you have lots of images, you want to run the optimization services on Mesos. And our cluster is based on some scaling strategy, and scaling is based on 2 factors: memory requirements and virtual CPU's requirement. So the problem with memory allocations is when you exceed the limit, the Mesos will kill the container. So that's why it's so important to have the smallest footprint possible. And the difference between allocated memory and used memory should be minimal. So if you tune your memory requirements a bit, you will get more containers and more instances from busy Mesos nodes, so you can compress more images at the same time. But that's not all, because another challenge is C library integrations. Which language will be the best to wrap the C library? And there are difficult questions for you to decide. The first one, how easy is it to integrate and to compile? How can you debug it? What's the performance and latency cost? How do you release it? And what about types conversions? So there are many languages which offers C library integration, but they all cheat, because most of them don't offer native solution, because C libraries don't usually play well with garbage collector. So you have Golang, Java, Python, and you get latency and poor performance when you interact with C functions very often. Even Golang, which I really like, has completely different compiler. It's like different code base just for compiling C libraries, which comes with huge latency. Debugger support is often missing, and you need to have separate tool chains just to integrate with Java libraries. So this is actually where Swift shines. It has single compiler. From the user perspective, of course, under the hood it's different. We have debugging, we have native function calls with 0 costs, and some sort of types bridging. So on the paper looks really well. It's C-based programming language, which native types bridging and 0 cost. And this is an example how Swift does integrate with C. We can directly call any C function and have some sort of implicit types conversions, which are and good and bad, depends how do you like it. But the nice thing is the killer feature is to have many pointer types, to have typed pointers, to make memory operations safer. So for instance, unsafe pointer and unsafe mutable pointer are different, so for reading and writing to memory, for example. And from performance perspective, Swift is really fast. These are the benchmarks from benchmarks game. So it shows how faster Swift is in comparison with Java. 3 times lower memory usage. It has value types. It has no garbage collector, and we have predictive performance. Of course, there's no Marcin sweep garbage collector in this meaning. So how is it possible? This guy Chris Latner is creator of Swift, but at the same time he's a C-Lang LLVM guy, so he knows what he's doing, and he even says that Swift is a C language killer and not other languages killer. It's like direct C language competitor. But of course, this is the first server-side edition, the first server-side conference here, so we all knew that this is completely new language and this is completely new world. Like, we are discovering something new here. You are innovators, you are the early adopters, you are the excited guys, so we can say that the things are a little bit wild today. So for Allegro, it was more like R&D journey. Like it was more like journey than adopting something polished and corporate, easy and ready product. And that's fine, because at Allegro we love experimentation, and we really wanted to try it out. So we tried to wrap these libraries in microservice based on Swift 4.1, Swift Package Manager, Vapor 2 at the time. Now we are porting it to Vapor 3, GCD, and of course the most important thing in microservices are what? HTTP client is the single most important thing to have it stable. So to experiment safely, you have to prepare everything, and you have to have a good experimentation platform. So after choosing server-side Swift, we had to prepare runtime environment on Mesos, to prepare in-house Docker images for Swift, to plug it into ecosystem, continuous integration, to prepare one-click deployment, security checks, compliance checks, auto-discovery, logs, and metrics, so and implement microservice contract, of course. So there is a lot of investment. And first one, microservice contract. What's that? Microservice contract is a set of rules for container to behave, to not get killed by Mesos, to play well with the environment. And for example, there's a specific endpoint status ping for health checks. If the endpoint is not responding, auto-healing will kill and restart the container. And adding routes, closures with Vapor was really easy thanks to routes and closures. So we've built this function into a common library called Swidamio, like Swift Andamio, like scaffolding. So this is reusable code for each microservice. And then you have three environment systems. Because containers are immutable, part of the functionality have to be moved out of the container. So we have to write client libraries to implement the configuration fetching, logs, and metrics. For configuration, we use Vault, which we built HTTP software on top of Vault. So when containers start, it fetches configuration from outside of container. For example, the database password. So we had to create this wrapper. And configuration is in the separate file kept on another server inside the Vault, which is, by the way, encrypted. It's a download over HTTPS. And next, there is a logging. So Vapor comes with its own logger, but it was not as flexible as we wanted. That's why we wrote a custom logger manager class to be able to plug different backends at runtime. And I'm really happy that there's a proposal to make something better, to unify a logging between many different frameworks. That's really nice. So we wrote logs-appender just to put logs to Kibana logs, and it's working fine. You get the logs from all of the containers in one place. And the last thing was metrics. So performance information such as queue time, compression time, are all sent to Graphite/statsd. Today, we are changing it to the Prometheus system, so we are looking closely at beautiful Swift metrics by IBM, which is really handy, which is really nice, but we want to make it more in a more general fashion across the many different frameworks. So you get some metrics. So in short, implementing the microservice contract consists of implementing all of these clients for systems. And there is second part, integrating C libraries. And this is another challenge because you have to decide if you want to link to system libraries, if you want to install it via Homebrew, for example, install MozJPEG via Homebrew, or and then you have faster compiles. Then you have a package manager, which is responsible for updates, or your sources are included, vendored by you, and then there is more customizability, but compilation time is much longer. So for MozJPEG, we used external MozJPEG library, but since pkg-config doesn't come with Homebrew, we included all the sources within the distribution package for pkg-config only. And the manifest looks like this. One C library is built from many different modules, so such as cpng, clib, image quant, cpng quant, and so on. So it was easy. I was surprised how easy it is to include and C code and to divide it into submodules. So I really like the new Swift Package Manager and its products. But it would be even better not having to create some wrappers around C repositories at all. So let's look at this small snippet how to talk to C library. You will likely be using data type. And it's nice to see it working reliably with Linux Foundation, because 2 or 3 years ago it was different quality. So now data works really well. To access individual bytes, you of course use with unsafe mutable bytes closure to access the pointer, and then we obtain the reference to write to the size variable. And sometimes you have to use fmemopen function for libraries which accept file arguments. And this was the case with MozJPEG library. But pretty much it was really easy to write the code. And if you need to cast raw bytes into specific type, such as uint8, you can use helpful with memory rebound function. Of course, remember to deallocate memory. So this is quite okay. Did we use pkg-config? This is the question. We try it, but we have some challenges, because pkg-config on Mac works only if you set pkg-config path, so we have to set pkg-config path to get another config. So it's like recursion. In order to get, you have to set. So it was actually funny, but we also had some problems with SPM. So we ended up with, so make file with compilation flags, and it compiled, but Xcode didn't like, so we have to overwrite Xcode settings with custom flags. But it works. It worked finally, so we were happy that it finally worked. The nicest part is that debugging work with C and Swift code and Xcode. It is really important when you write low-level C code. You want to have a good debugger, really want. Of course, there are some challenges. For example, what happens when C code crash? This happens. You have to download core dump from remote server just to inspect it, and we should come with something better. And I'm really excited about the guy who discussed the stack trace handler today. It would be really nice to have it. So this is something worth of fixing. Custom stack trace handler would be awesome, and also memory profiler on Linux will be also really nice. Given that, the third part, if we have something that compiles nicely, we can debug it on developer instance. We have all of the environment managed. What's next? So when we build something, we wanted it to deploy, and somebody says that coders love to code and they hate to deploy, something like that. So I want to say that building the software for data center, I'm focused on making deploy loved by developers. So this is why it was really serious to me to make deploy as good as possible. So we compile everything on Docker. And in the first stage of our experiments, we built on Docker and we ran it on Docker, and it was fine. But for our specific needs, it was too slow to scale. So now we compile everything on Docker, build a package with all of the dependencies, and just unzip and run native on Mesos. And to enable everybody to create services with Swift, I built a template for our deployment platform to do it as quickly as possible, and I will show you now. So today, when you want to create Swift microservice for some performance reasons, you just go to our platform as a service. Of course, it's internal only for Allegro, so it's not commercialized yet. But our platform as a service makes this simple. You type the name of microservice, you type the description, you put somewhere in the organization structure, and you click create, and it's creating all of the repositories from template, like Vapor template, and it builds the Docker image automatically from the template. When it builds, it creates a zip file which will be transferred to this management console, where you can select the version and deploy it directly to production. It takes about 3 minutes to deploy, and this is actually fun because you don't have to think about infrastructure. Under the hood, there are dozens of systems to make it work, but the benefit for developer is that just to click, 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 choose the version, and it works. So under the hood, you have created CI pipeline, you have safety checks, compliance checks, everything in one click. So what are the results of our experiment? PNG files are today compressed by default with at least a 30% reduction in size. But the nice observation is about the memory usage. So before compressing the file, this is memory usage of minimal Swift microservice. It's just 25 megabytes of RAM before the image is compressed. And the minimal Java micro, as they say, service is 250 megabytes. It's like more like macroservice, not microservice. And it even doesn't do anything. It's just running. And it probably needs twice as much memory if you want to do something. And it's nice in comparison to see Swift during compression of these large images. Takes only 49 megabytes of RAM. Of course, these are not 5 megabytes images on the front side. It's more like 1,000 pixels wide. So we can shrink it to 49 megabytes of RAM, only that. So as you can see, the memory is like linear. The RSS is not reported as reclaimed to the operating system. So if you compress the smaller images, the amount of memory is like cached. So it's like if you don't exceed the limit. And what about startup time? Startup time is just 0.2 seconds. It's like servers-like. When we talk about serverless, we talk about 200 microservices, 200 milliseconds for microservices. So it doesn't need JVM startup time. It doesn't need warm-up time. So this is actually the territory of serverless area. But you might ask, does it scale? So I've prepared comparison. How does it scale in comparison with Java microservices? On the top, we see Java. On the bottom, we have Swift. And to make this fair, Java will try to scale 10 instances, and Swift will try to scale 100, just to make fair. No offense. And to be even more fair, Java has some JVM pre-installed libraries. Swift has nothing pre-installed on the server, so we put everything, all of the dependencies in Swift case. So Swift had to move all of the image across the network. So let's start. We will have two stages. The first stage will be black bars when the images are transferred to the destination, and the green bars when are the actually containers started responding, when they are healthy. So it will change during the deployment. So let's start. Java try to 10 and Swift 100. And Java is ahead, like copied all of the images, and Swift has spread 100 images. Java started to look for first instance, and on the server side Swift, there's 39, 60 instance already responding. There's in both data centers, so Swift is done. And we are waiting for Java. Well, so this is 200 instances in both two data centers. It's not mocked up, it's real, in just 40 seconds, including health checks. So it's not just running and saying that it's healthy. We waited for first pong from status ping, and nothing was pre-installed on the clusters. So this is really area where Swift shines. So what's next? We just got started with PNG on one showcase area. So the next step is to compress more areas with PNG and JPEGs. And I'm happy to say that Quanta is going open source in November, so we'd like to share everything, because open source is at the core of Allegro engineering culture. And of course, the good part is that Swift is fast, it has predictive performance and fast to scale. It has amazing C libraries integration, powerful language with safe code constructs. But there are, of course, missing parts like framework agnostic libraries, like logging metrics, test bundles, which, by the way, is during the development, so it's changing. Stack traces will be good, and memory profiling on Linux, and of course, better tooling. So what is Swift good for? It's the best for performance-oriented microservices. It's safer for C libraries wrappers. It has potential for machine learning and C-Python integration thanks to dynamic callable functions. And you tell me more. Thank you.